Hi everybody. So I was looking at that example in the textbook that I told you to read yesterday, and even I was like, what the heck? It was so hard to understand. And the thing is, when you're just shown how to do this work, it's so easy. In fact, you might want to make a starred note on this page somewhere, indicating to yourself that this is the question in grade 12 that everybody jumps to on the final exam as soon as they sit down and open up the final exam. They usually do this question first because it's so easy. But it takes a long time. And that's going to be a little bit of a detriment on this video because the video is going to be long, but the work is very easy. Let me show you how it works. This question's from last semester. Hopefully you printed these pages out already because you're going to need them. This question's from last semester. It's the same setup, the same idea as the one in the textbook, but there's slight little changes to the question that I did myself because I think that it makes more sense. And I can't even I can't even explain why. You just have to trust me on that one. So there's two balls that are undergoing what's called a glancing collision. And all glancing means is that one ball is just sort of scraping by the other one in such a way that they're both going to go off on angles. And we have to predict, in this case, I turned the question around a little bit from the one in the example. Ball number one is moving. It hits ball number two, which is actually also moving, a very slight amount. And ball number one is deflected in the way that's shown here. It's deflected 60 degrees from the angle that it was, the direction that it was heading. It's got a new speed. It's slowed down a little bit. And the question here is, what happens to ball two? Where does it go? How fast does it move? Just what are the conditions of motion after the collision? So this is a collision. It's conservation of momentum. But the problem is the formula that you are using for conservation of momentum, and it's going to be the same formula, don't worry, but the formula that you are using is only good in one dimension. In other words, it's only good left or right, or up or down. It's not good for angles like this. You won't be able to predict the angle answer on ball number two using a conservation of momentum formula. So the gist of the question is you have to break the question up into all x direction and all y direction. And you have to do conservation of momentum twice for each one of these questions. Once for everything in the x direction and once for everything in the y direction. And that's the only way you're going to get the answer in the end. So let me show you how this works. You might be confused a little bit along the way, but by time everything's said and done, you're going to realize how easy it really is. So the first thing that we're going to have to do is, let's conserve momentum in this question, but only in the x direction. Okay, so we are going to do a full conservation of momentum formula, just like you did on the work from 2 days ago, but only in the x direction. So the left and right direction. In the left and right direction, there are two objects in the beginning, and in the end, they don't join together, so there's also the same two objects in the end, but slightly different momentums because of the changes. So I'll put those little prime signs on there, those little ticks to indicate that they're not the same. Okay, so each one of these momentums has its own formula, just like last day, mv. But every single one of them has its own mv. And you want to label those so that you don't get confused as to what's what or cancel masses. That would be the worst thing to do. This is M1V1, M2V2. And then afterwards, M1V1 prime, because it's afterwards, and M2V2 prime. And all you're going to do is substitute into this formula. But I guess I should back up a step, because back in the beginning, this velocity here is on an angle. It's 3.5 meters per second at a 60-degree angle. And just like I've been telling you since the beginning of this class, the very first thing you do on any question when you see an angle in grade 12 physics is break the angle up into horizontal and vertical components. So we don't want this. We don't want 3.5 meters a second at a 60-degree angle. We want to know what's the horizontal component of this and what's the vertical component of this. So 3.5 sine 60 degrees for across from it, and 3.5 cos 60 degrees beside it. Can I just do that on a calculator without writing anything else down on the page? 3.5 multiplied by the sine of 60 degrees. Okay, and I'm going to write this on there. That's 3.03 meters a second in the upward direction. And I'm going to work out 3.5 cos of 60 degrees. That's 1.75 meters per second. Okay, so that's what we want to use. We don't want to use this. We don't even care about the 60 degrees. That's gone. We want those two components of our answer. So let's put this together for the x direction. The first mass is 85 kilograms. And it has a speed of 4 meters per second to the right. And remember, you have to put signs on the speeds. So I'm going to make this positive, just because positive sounds like the sign I want to use for going to the right. The second mass in the beginning is listed as a 60 kilogram mass. And I wanted to make it at rest, but I didn't because I wanted you to see how this calculation works. So in the beginning, I put this down, that it's moving also to the right with a small speed of 0.3 meters per second. Okay, so then the collision happens, and we move to the variables on the right-hand side of the formula. Mass number 1 is still 85 kilograms, but the speed is now changed. And not only the right, the speed is changed, and we're only going to use the component of it. So the speed in the x direction only, this is what you have to focus on. X axis only, x direction only. The speed of the 85 kilogram mass after the collision is forward, or to the right, 1.75 meters per second. Sorry for twisting the page on an angle here. I bet it's kind of hard to read on your screen, but I'm trying to lean over top of a video camera and write at the same time. It's a little bit difficult to keep things straight. The second mass in this question is still 60 kilograms. They haven't joined together or separated or anything like that. And the final speed, V2, after the collision, is the unknown. So what you have here is a calculation that we already did last day. It's exactly the same as the homework from 2 days ago. You want to isolate for V2 and solve. And I don't have answers in front of me, so I'm doing this kind of live on the fly here with you. I'm going to do 85 times 4, add it together with 60 times 0.3. Isolating from the other side, I'm going to take off 85 times 1.75 and divide by the mass in the end of 60. So the final answer in this question is positive, that's important, 3.49 meters per second. So you have to think about what this answer is. That's not the final answer. That is the final speed of ball number 2 in the x direction only. So more on what that means in a minute. Now we have to do the same calculation for the y direction. So same thing, you want to do a complete conservation momentum question for the y direction. In the y direction, there are 2 objects in the beginning, and they don't join together, so there's 2 objects in the end. And before I even write down MV, 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 just take a look back in the beginning and think about this for a second. So in the y direction, in the up and down direction, the first mass is moving completely to the right. It doesn't even have any movement in the up and down direction. And V2 as well. Mass 2 as well. It's moving 0.3 meters per second directly to the right. It's got nothing happening in the up and down direction or the y direction. So I could wait until the next line to substitute in zeros for the speeds, but actually I'm just going to do that right now. These are both 0. There is no speed or momentum, therefore, of ball number 1 up and down, and there's no momentum for ball number 2 up and down. So they're both zeros. That doesn't mean that's going to kill the equation. It just means the left-hand side is 0. So let's fill in the right-hand side, because we still have this. We still have mv1 prime and M to V2 prime to fill in. So actually this is going to work out a little bit easier because there's less to do. The mass of ball number 1 after the collision, 85 kilograms. The speed of it in the y direction only though. So think about it. Don't use the original 3.5. In the up and down direction, in the y direction only, it's 3.03 meters per second. 3.03 meters per second. And I'm going to use a positive sign because it's pointing up. I like using positive for up. I don't know why you would use a negative for up. The second mass is 60 kilograms. And we are looking for V2 prime. So there's the equation. The left-hand side being 0 is not going to be any kind of a mathematical problem. You can still solve. So V2 prime, when you work this one out, 85 times 3.03, bring it to the other side, divide by 60, you get an answer of minus 4.29 meters per second. And that minus is important because that means it is down. So these are the two sub answers. And you have to think about what these two answers mean. Basically it means this. Let me put a page here beside it. Basically it means that ball number 2, after the collision, has two components to its motion. It's moving to the right 3.49 meters per second. But in the y direction, it has a component of negative 4.29. In other words, it's moving down 4.29 meters per second. So you see, these two answers from the first page, they're not final answers. They're components. They're the x component and the y component of the answer. And the signs on them are important because it allows you to actually draw the direction of those two components. I mean, if you have any experience playing pool, if you were to hit two balls together like this and ball number 1 deflected up, I think probably you, through common sense, can understand that ball number 2 will deflect downwards and also to the right. But you don't necessarily need to know that. The answer will show you that in the end if you get it correct. So this is the answer we're looking for. And this is why these questions are long, but again, it's why these questions are easy, and they're using the same mathematical skills that we've been using for weeks. You are just looking for side C of a right angle triangle. And it's going to be a, I almost said a net speed. It's not a net speed. It is the final speed. It is truly V2 prime. This one, I guess, is V2 prime X, technically. And this one is V2 prime Y, the X and the Y component. We want actually V2 prime. So you know how to finish this off. And you need this. You need an angle. You're going to need to say what a final heading is in the end for these questions. So you've got the full shebang here. There's no shortcut. You basically have to do a full Pythagorean theorem calculation and solve for side C. And you have to do a full trig calculation to solve for that angle inside the triangle. And you don't even need to watch the video at this point to do this because I'm sure you know what you're doing. But just to get an answer for everybody to copy if you don't have a calculator and you're not doing it on a calculator at the same time. So that comes out to a final answer of 5.53 meters per second. And I'll do a tan calculation because I don't like to use my answer from Pythagorean theorem. I'd rather use the original values. Opposite side 4.9 meters a second. Adjacent side 3.49 meters a second. Cancel the units. And your final answer here will be what? Let's see. Make sure your calculator is not in rad mode because that'll totally mess you up. You get a final answer of 50.87 degrees. So my final answer in this question, are we using north, south, east, and west? No, we're using up, right, left, down. So this would be to the right. And if I round that, 51 degrees down. And if you really, really want to do things absolutely correct, the so-called university way, when you have two different ways that you can possibly write an answer with an angle in it, you're always supposed to use the lower angle in the middle. So a more correct answer would be that it's down 39 degrees to the right if I had drawn my components the other way. Sorry, that was off the screen. I just shifted the page up so you could see it. Yes, right 51 degrees down, but a better answer would be down 39 degrees right. Okay, that's only one example, and we're at 15 minutes. I told you, these questions are long. You can shut the video off right now if you want, but I don't think you should. I have an example number 2 on here, and it's the same thing. I mean, if you want to shut the video off right now or pause it and try example 2 on your own, and then play the video again, you can see if you did it all exactly right. But here's the kind of question you're going to get next year. There won't be any diagram, it'll just be a description. And the first thing that you have to sort of do is interpret what is being said. I always drew a picture, or at least tried to roughly sketch it. I would make an X and a Y axis, and I would just sort of read what it says. A 50 kilogram mass is moving 10 meters a second north. Okay, well that's good. There isn't even an angle there. 10 meters a second. 50 kilograms. I'm just going to make it a ball. Okay. It's struck by a 30 kilogram object moving at some unknown speed. Okay, so a 30 kilogram object comes in from some direction, strikes this, the two objects join together, and in the end, after the collision, it says the two objects join together and are traveling 20 meters a second east, 15 degrees south. 15 degrees, 20 meters a second, and this is a large object that is the two objects joined together. So you might be able to, I don't know, sort of use intuition on this question to say to yourself, well, the first object coming in, a 30 kilogram object, it must be coming from this direction and this direction if it's going to result in something like this in the end. Maybe you can predict. I mean, it's got to be coming in from the left, and if it's going to hit this object and push it downwards, it must be coming from up and traveling really fast. You don't need to do any of that. See, the nice thing about mathematics and being organized is you don't even have to have any clue whatsoever what the answer is going to look like. You can just let the math work itself out. We've got a 50 kilogram object and some other unknown object, and here's what it does in the end. Okay, so let's just begin. So the first thing you do is you do a calculation for just the x direction. Actually, let me back up a step. The first thing that you should do, because you should know you're going to have to do it, is this is on an angle. So I would immediately, before doing anything, break this up into two components. It's a 20 meter a second vector at a 15 degree angle. So you want to do 20 sine 15 degrees for the side opposite. That's 5.18. And you want to do 20 cos 15 degrees for the side beside it. That comes out to 19.32. Okay, so those are the values that we're going to use. So first, let's start with the x direction. There are two objects in the beginning of this question, and unlike the last example, they join together. And they become a total object in the end. Okay, so each one of these has an M and a V. And I'm not going to use any prime signs on this question because the variables don't need it. They're all different. So I'm really not even thinking at this point. I'm just subbing in numbers that are in the question. There isn't a lot of thinking required, and that's why this is nice. The first mass is 50 kilograms. The speed in the x direction, oh, I didn't see this coming. I would have canceled it out earlier, but that's fine. I left it until this line. The speed in the x direction is 0. It doesn't have any. The initial speed is 10 meters a second, but that's up. And there is no angle here, so it's all up. This is 50 meters a second times 0. There is no momentum on that object. The second mass is 30 kilograms. And we don't know what's going on with that object. We don't know what the V2, the speed of object number 2 is in the beginning. That's what we're going to solve for in this question. But we do know that the two masses link together in the end. So they're going to be 80 kilograms. And we do know the final speed. But be careful, don't use 20. We have to use the component of the final speed in the x direction, 19.32 meters per second. So there's only one thing to solve for. And actually this is a really easy rearrangement because this entire term over here becomes 0. So very simply solve for V2. And remember, you don't need to guess what the sign is on the answer in the end. Let the math work itself out. You can see from this that it's not going to become negative. So the answer is 51.52 meters per second. There's something that I think you should add in here, because I forgot, even after all my lecturing on this, there should be a sign on the 19.32. I should have put a plus sign here. See, I knew when I wrote it that it wasn't going to affect anything, but you can't think like that. You have to put signs on the speeds every single time. And then when you get an answer, you have to make sure that you have an answer on the speed in the end, because you're going to need to know it. You're going to need to know what way to draw the vector in the end. So that means that in the x direction, the answer to this question, 51.52, but that's not the final answer to the question. So we still have to look at the conditions in the y direction. So go back to the beginning of the question now and think about it again, but only look at what's going on in the y direction this time. So one more time. There are two objects in the beginning and they join. Each of these has its own momentum, its own m1 v1 or m2 v2 or whatever, mt vt. Now in the y direction I got to be a little more careful because everything has values. First of all, you've got a 50 kilogram mass traveling up 10 meters a second. Then there's a 30 kilogram mass, and we don't know what it's doing. V2, an unknown V2 in the y direction. The total mass, 80 kilograms, because they join together, and the speed of the total object in the x and the y, or sorry, in the y direction only. So going back to my diagram, this one here, in the y direction only, it's 5.18 and it's down. And I need to stress in my calculation that it's down. I'm going to use a negative for down. 5.18 meters a second. Okay, so there's only one thing to solve for, V2. Be careful with the math here. It's a little bit more, I mean, it's not challenging. It's just grade 9 math, really. But be careful that you do the signs right. And I might have to check this one twice just to make sure. But let's see. Let's see if I can do this all in one shot. Minus 500 divided by 30. Okay, so final answer is negative. And you guys should be checking this and checking my math along the way, because I'm doing this live too, so I could make a mistake. Okay, so at this point, here are the two answers. Neither one of them is the final answer. But there's two answers. So these two answers say, if you look at the signs, they say that the true speed of the object before the collision is in the x direction, it's traveling to the right, 51.52. And in the y direction, it's traveling down, 30.48. And that's all the signs are good for. So it's kind of like work that we did last week and the week before. You don't actually use the signs in the calculation in the end. You just use the signs to design the picture of what it looks like. And then the final answer, and by coincidence only, the final answer in this question is going to kind of look similar to the last question. It's also going to be down and to the right. So we need two things. You need side C of this right angle triangle, and you need to work out the angle inside. I'll spare you those details writing it out on the page. I think you should. You should probably write it out to finish this off and have complete calculations in your notes. But I will just work it out quickly on my calculator here. You will get a final answer of 59.86 meters per second. And that'll be the absolute final answer for that initial speed of object number 2. And when you work out the angle inside, you will get 30.6. Boy, that was a coincidence too. Wasn't the previous answer 31 degrees? Oh no, it was 51 degrees. Okay, so final answer to this question. Let's say that it was an online assignment next year and you would have to enter the exact answer. Here's your final speed. Here's your final angle. So you would, and if you were doing proper significant digits for this question, if you look back at the beginning of the question, the lowest number of significant digits is 1. There is 1 significant digit. So your final answer to this question, if you were typing it in as an online assignment, would be 60 meters a second. And your direction would be right, I want to say 31 degrees, but 31 degrees would be 2 digits. If you were rounding this to 1 significant digit, the answer would be 30 degrees down. And I wouldn't have to modify it this time because 30 degrees is the lowest number that could be written inside the brackets there. I could change it to down 60 degrees to the right, but that wouldn't be the most correct answer. So that's the final answer. Sorry for this mess. I hope what you're writing on your page doesn't look as messy and in the same spot as what I have on my page. These questions they're awesome. They're great exam questions because they're so easy and so sensible. There's a lot of room for a math mistake as you go along, but I mean, big deal. If you make a math mistake or you mess a sign up and you forget to put a negative in there, what, you're going to lose 1 mark out of like 10 or 12? These questions are worth a ton of marks because there are so many steps. So tonight's homework, there are only 3 questions, but I warn you, they're going to take you 10 minutes each. So you're looking at 30 minutes just doing those 3 questions. Actually, I've got them here. 3 questions. If you have notes from last semester, there were 4 questions. I deleted one of them because it was kind of repetitive. They're the same. They haven't changed at all. So if you have notes from last semester to refer back to, you can see someone else's work for these 3 questions. The answers are here. They've been tested a couple semesters in a row, so they're for sure the answers. And I will post fully written solutions for these questions so you can go through your work. And if you work all these questions out and you don't get these answers for one of them, you know, I want to say search around and see if you can find your mistake, but the questions are so long. I'll post the solutions and you can go through the solutions line by line by line looking for where you did a math error, and you'll be surprised at the crazy silly little math error that you'll find. Sorry that this video was long today. 28 minutes. Oh boy, I think that's a record. But you know, I'm glad you can follow it line by line at your own speed and pause it if you need to. Thank you, and I'll post full solutions later on.